Everybody, Mr. Rubo here, and we're going to look at 5-1, 5-2, and 5-3 today. So it starts with just parallel postulate, and then we'll get into quadrilaterals. So, yeah, it's really a few simple proofs on 5-1. So we have given that AB is parallel to DC. Okay, so I'm going to use some of those guys. And then at angle B is congruent to angle D. So we want to prove that the two triangles are congruent just with this information, which what ends up happening is we have some nice things because of parallel lines. So it's a very short proof here. So we given that we have parallel lines, and then one of our big things is if parallel lines, then alternate interior angles are congruent. So that would be BAC and DCA. So those two angles right there are indeed congruent. And then the other given was that angle B is congruent to angle D. And then we have the reflexive property that AC is congruent to AC, which means we have enough to prove that those two triangles are congruent by angle, side. So yeah, there's that first proof. Second proof is right here. But just kind of going through the plan here, PQ parallel to RS, and PR is parallel to OS, or I'm sorry, QS. My thing got covered up slightly, but that's fine. And we want to prove that the two opposite angles are congruent. Now, we'll learn another way to prove this a little quicker, but right now, the way we would prove this is with our parallel lines. So we would know that PQR is congruent to QRS because alternate interior angles are congruent. And that would be because PQ and RS are parallel. And then we end up doing the very similar process for these two angles. Oh, my pen doesn't want to write. There we go. Those are also alternate interior angles, but they're of the two more vertical lines, so QS and PR. So we get those two, and then just like the last proof, we got a reflexive property. So we got angle side angle here, and then by CPCTC, we get those two congruent, which is what we wanted. All right, last one here. Now that we don't have any triangles here, we just want to prove that those two angles are are congruent. So we are told AB parallel. I'm sorry, A and B are parallel, and then C and D are parallel. So we end up with a lot of things we can say here, but right away, angle 1 and angle 2 are corresponding. And guess what? So are 2 and 3, which means by the transitive property, we can say that angle 1 is congruent to angle 3. So here is this proof. Nice and easy, nothing too crazy. All right, so now on to 5-2, which 5-2, you guys have this lovely chart, which I'm going to bring up in a smartboard here. And we're going to fill this out. Now, there's a lot of information that's on this page, so pause the video as you need to, especially as we kind of write down these properties. But yeah, and if you need to write them elsewhere, that's totally fine. But a lot of this you do already know. We're just going to solidify it here. So in this chart, all of these are quadrilaterals. So quadrilateral is just a four-sided polygon. Okay. So yeah, that's it for a quadrilateral, and that's really the focus of this unit. All right, so we're gonna go down these left two here. So we're gonna start with this guy, which is a parallelogram, and parallelograms are quadrilateral with both pairs of opposite sides parallel. That is the definition. Okay, but there's going to be a lot of properties we will know and we can prove and we can figure out. And those properties are that opposite sides parallel. That is the first thing. The second thing we also know if it's a parallelogram is that opposite sides are congruent. Okay, so that's very helpful. The third thing is opposite angles are congruent, and by opposite angles, we are talking across the diagram. So from one corner to the next, but not next to each other, that would be adjacent angles. And if we were to have diagonals, or if we drew the diagonals in, they do bisect each other. And the last property is that consecutive angles or adjacent angles are supplementary. So the top and the bottom angles would be supplementary, or if you're talking left to right, right? So yeah, there are your 5 properties of a parallelogram. Again, if you need to, pause the video and then come back. All right, back to the overall one. We're going to do this one right here in the middle, which is a kite. Okay, so kites are quadrilaterals with 2 disjoint pairs of congruent sides. Disjoint meaning they are not opposite, they are next to each other. So yeah, kite has 3 properties. The first one is their diagonals are perpendicular. Okay, so if you drew their 2 diagonals in, you get perpendicular. And by the way, I guess I should have defined what a diagonal was. Diagonal is from one vertex to a non-adjacent vertex. Quadrilaterals, it's really just the one. It's one vertex to the vertex that is not connected to it. But you'll see when we get to more sided polygons, there's more diagonals. All right, the second one is that the BD is the perpendicular bisector of AC. And we prove that using the equidistant theorem, that A is equidistant to B. I'm sorry, D is equidistant to AC, and B is equidistant to A and C. So BD is the perpendicular bisector. Okay. And the last one is that angle A is congruent to angle C. You'll notice I do not say that D and B are congruent, because they are not. Not always. They can be, but then if that happens, then it's a different shape. And we'll talk about that. All right, so then we're going to keep going on this left branch, if you will. And this one, you guys should know a lot of these properties already, but we got a rectangle. So for a rectangle, it is a parallelogram with at least one right angle. And I say at least one because that's more with proving. We know that all 4 angles are right angles. But if you know it's a parallelogram and you have one right angle, you then know opposite angles are congruent. And then they're also supplementary with consecutive angles, which means all of the angles are right. So that's why we just say with one right angle. All right, then we know all angles are right. And second property is that diagonals are congruent. Now, this is one of those cases, and technically this has been true for all of them. Everything that has been true for the things above it is also true for the rectangle. So all 5 properties for the parallelogram are also true with the rectangle. The rectangle just had those 2 extra properties. Okay. Then next to the rectangle, we get what is called a rhombus. Okay, this one might be one that you don't see too often. But what a rhombus is where consecutive sides, it's a parallelogram with consecutive sides congruent, which in other words means, oops, I thought it was going to be that one, that all 4 sides are congruent. Okay, because parallelogram means opposite sides congruent is one of the properties, which then also means that we have all sides congruent because consecutive sides are congruent as well. So some of the properties, extra properties with rhombi are diagonals bisect angles. So the angles get bisected, not just the diagonals. And then diagonals are perpendicular bisectors of each other. And the last one is we have 4 congruent triangles when you draw in those diagonals. Okay. So yeah, there's a rhombus. Again, as you need to, pause the video. All right, and then we're going to go down to this very last one, which is everybody's favorite, which is a square. So a square is got all of these things above it, all the way back up to a quadrilateral, right? We know it's got 4 sides. It has all the 5 properties of parallelogram, all the properties of the kite, all the properties of rectangle, all the properties of a rhombus, and then it has its own, which is diagonals make 4 congruent isosceles right triangles. So not only does it have that 4 congruent triangles like a rhombus does, but it has even more specific isosceles and right triangles. Okay, so this whole left side, they're kind of all connected. They're kind of a family of quadrilaterals, if you will. Where then we have this one all the way to the right, which these are trapezoids. So two types of trapezoids we're going to deal with most often. There is trapezoid, which is just where we have a quadrilateral with exactly one pair of parallel sides. So we are defining it where it has one pair, only one pair. If it has two, then it becomes a parallelogram. So you have you have a trapezoid if you have exactly one. And just for sake of naming the two parallel sides, we call bases. They're the bases of our trapezoid. All right. And for trapezoids, there's really only one extra classification, which is isosceles trapezoid. So this we get a lot of properties with, but we have upper base, lower base, isosceles trapezoid. They are a trapezoid with congruent legs, and the legs are the two sides that are not the bases. We have upper base angles and we have lower base angles, and here's a bunch of properties. So lower base angles are congruent. Okay. Upper base angles are also congruent. And then diagonals are congruent, and lower base angles are supplementary to upper base angles. So if you take one upper base, one lower base, they add up to 180. Okay. So yeah, there is a lot of properties for quadrilaterals. I do expect you to know all of these, but we will kind of slowly work our way. I don't expect you to know all of them this second, but a lot of them you already know. Okay. So yeah. All right. So then back to our notes here, and hopefully you filled that out. Again, if you needed to, pause the video and take notes. We're going to go to number 3 here, page 3. So based on that graphic organizer, I want you guys to try this always, sometimes, never, and fill these out. And then come back to the video and we'll go through all of the answers when you come back. All right, sweet. So hopefully you tried it out and did these all. So a parallelogram is a quadrilateral. That is always true. Okay, you have to have 4 sides to be a parallelogram. Just how that tree works. All right, a parallelogram is a rhombus. Well, those two were connected, but the parallelogram was higher, which means that this is only sometimes true. Okay, a square is a rectangle. This is always true because a square was all the way down at the bottom, so it has all the properties of the ones above it. A rhombus is a square. Well, this is sometimes, because again, a rhombus could be a square, but it doesn't have to be. It could just be a rhombus. A trapezoid is a parallelogram. This is our first never. A rhombus is equal angular. This is sometimes. Equal angular, meaning all angles are equal. Well, if that is true, then it ends up being a square. Okay. A rectangle is equilateral. This is also sometimes. Because, again, if it was equilateral, it would end up being a square. But rectangles are not always square. A trapezoid is a kite. This is never. The trapezoid was on the right side of our graphic organizer. Kite was on the left. They were never connected other than at the top of being quadrilaterals. So there you go. A kite is a rhombus. This is sometimes. And again, it's because the kite was higher up on the scale or on the diagram. And then a rectangle is a square. This is sometimes. This is something you've heard since you learned rectangles and squares. But again, there you go. All right, so hopefully you did well with those. And that's all this video had for today. So thanks for watching. Have a good